we want to test this series for convergence or divergence. So we want to do the alternating series test because this is an alternating series as evidenced by this part of it. So with the alternating series test, you want to get b sub n, which is this other part. That's b sub n, which equals n² minus 1 over n³ plus 1, and you have to look and see if when you take the limit as n approaches infinity of that piece, b sub n, if that equals 0, first of all, and second of all, if this is decreasing for each term. So is b sub n plus 1 less than b sub n? In other words, you've got to make sure that it's decreasing and that its limit as n approaches infinity equals 0. That's your alternating series test. If both of these conditions are met, then this converges. This converges. So let's check. If we take the limit as n approaches infinity of this, will it converge to 0? Yes. Yes, it does, because we have a higher power in the denominator compared to the numerator. So you can think of it as you plug in infinity into here. This is infinity cubed, that's infinity squared. Which infinity is bigger? Infinity cubed. So that means that the denominator increases faster, and you're dividing something by something which is larger, infinitely larger, so you do get 0. Now, the second part, the second piece, that's the first piece, and we got that. Is b sub n plus 1, in other words, the next term, going to be smaller? Well, you don't even really have to plug in n plus 1 for all n's, because you could just look at it. I mean, obviously, this it has a larger exponent. Like we said, this is cubed, this is squared. So each successive term is going to have a larger denominator. So that means it's decreasing. So yes, that means that this series converges. It converges by the alternating series test.